But first we have to go here into our PQR. In here we're going to fill the properties of the filler metals that are going to be used in our procedure test. So for gas tungsten arc welding we have filler metal F number 6, the same for flux core arc welding. And we got there because this information was taken from the manufacturer of filler metals, and this is the adequate filler metal for our base metal, and this can be checked exactly on our table KW 432. So we have here SFA 5.29 and 5.28. All classifications are F number 6. So our filler metal is F number 6. This F number cannot be changed in any welding joint qualified by this PQR. It must be used only this F number 6. And now we go here into the WPS range of qualifications, and we, as we can see, put our F number 6 for both processes as range qualified by our procedure test. So now we go again to our essential variable table, and the next essential variable is KW 404.5. This refers to the A number. This is the chemical composition of the welded metal. And so let's go check this paragraph. So this means that a change in the chemical composition of the weld deposit from one A number to any other A number in table KW 442. We'll go there in a minute. Qualification with A number 1 shall qualify for A number 2 and vice versa. So in this table we go here, and our supplier says that its filler metal is A number 3. So being so, we go here and we had the weld metal analysis A number 3, and so now we had our weld metal analysis A number 3. Also in the range of qualification WPS we had the same indication. That means that our A number qualified is this one. So next, let's move on to our next essential variable, which is KW 404.23, filler metal product form. Well, let's search the paragraph, respective paragraph. here we have it. A change from one of the following filler metal product forms to another. Well, in our PQR we have already defined that in gas tungsten arc welding we have a solid type of filler metal, and flux cored arc welding we have a flux cored type of filler metal product form. So this variable tells us that we cannot change the product form of filler metal. So in the range of qualifications it must be indicated just that. The next essential variable for this process is I would like to tell something. These variables that I'm talking are the same for both processes, so we are doing at the same time, but there are a few variables that are only applicable to cast tungsten arc welding. We will see that in a moment. So going back to our essential variables, we now must take a look at the next one, that is KW 404.24. And so we have here is changing, adding or taking supplemental or changing supplemental filler metal. First of all, we're going to search for this essential variable, and here we have it: the addition, deletion or change of more than 10% in volume of supplemental filler metal. Well, we don't have in our welding procedure test supplemental filler metal, so we're going to add exactly that in our PQR and in our WPS range of qualifications. We're going to add the indication of, this is a little bit small, I'll try to let me see, addition of up to 10% volume of supplemental filler metal. This is the range qualified in this essential variable for this welding procedure test. Or what it means is that in the welding joints approved by this PQR, we cannot use more than 10% of supplemental filler metal in welding the welding joint. Next one, 404.27. Here we have it, where the alloy content of the weld metal is largely dependent upon the composition of the supplemental filler metal, powder filler metal. Any change in any part of the welding procedure that would result in important, well, this means that we can have some restrictions here, but since we don't use any supplemental filler metal, this essential variable does not apply to our situation. So now we pass on to the next essential variable, which is KW 404.30. And this is about the deposited weld metal thickness, and a change in the deposit metal thickness beyond that qualified in accordance with this paragraph for procedure qualification, except as otherwise permitted in other paragraphs. So we must go here, and now we are again in this table. Well, we have seen the welding joint that we were going to use. So we consider that welded metal thickness for the gas tungsten arc welding is about 4 millimeters, as we have seen early in the weld joint design. For flux core arc welding, it's the rest for making 25.4 millimeters, so it's 21.4 millimeters. And on this table we can determine the maximum thickness, smaller t, of deposited weld metal. Well, since the thickness of our test coupon is 25.4, it's somewhere between these values, 1938, so is somewhere in this line. But now we have here an issue, because this is the column that is important in this essential variable, and what we have here is when smaller t is smaller than 19 is one thing, but when t is bigger than 19 is other thing. So for Keto we have a t of 4 millimeters, so we have a qualified maximum thickness of deposited weld metal of 8 millimeters approximately. So we go here and up to 8 millimeters. In the case of the other process, flux core arc welding, the thickness of deposited weld metal is 21.4, so we have this line. This is the line that we are interested on. So the maximum thickness of deposited weld metal qualified is 2 times capital T. So since capital T is 25.4, we have 50.8 millimeters as maximum deposited thickness. For fillet weld, we go here to this table, fillet welds qualified by groove weld tests. Next variable is number 404.32 for the low voltage short circuiting type of gas metal arc process. When the deposit weld metal thickness is less than 13 millimeters, an increase to deposited weld metal thickness. Well, in this case, this essential variable does not apply, because the deposit weld metal thickness of the flux core arc welding is bigger than 13 millimeters, so this variable does not apply to our situation. Next variable is KW 406.1. This is due to the preheat in the welding procedure test. So a decrease of more than 155 degrees centigrade Celsius in the preheat temperature qualified. The minimum temperature for welding shall be specified in the WPS. So in our PQR, now this is already done. These are our positions. This is not an essential variable in this situation, but this is going to be our welding position. This is a horizontal position for welding. No weld progression. And in case of preheat temperature, we have 250 degrees Celsius, and according to indications of the manufacturer, we also have 250 degrees Celsius for interpass temperature. This is the interpass temperature used in the welding procedure test. Temperature shall be maintained through the welding cycle and sometime after completion of welding. So in the WPS range of qualifications, we have for the positions, all positions permitted by filler metal with welding progression up and down is qualified for that. The positions of fillet, all positions permitted by filler metal, but we have to realize that this procedure does not qualify for short circuit transfer mode, so some positions may not be available due to that. So in case of our preheat temperature, we have minimum 200 Celsius. This is the minimum temperature permitted. Interpass temperature maximum 300 degrees Celsius, and also maintained through welding cycle and sometime after completion of welding. So we have a minimum preheat temperature of 200 degrees with about 50 degrees less than our procedure qualification record. And so now let's go for another essential variable. We have KW 407.1. Well, in case of the post-weld heat treatment, separate procedure qualification is required for each of the following. For P numbers 1 through 6 and 9 through 15F materials, the following post-weld heat treatment conditions apply. No post-weld heat treatment. So these materials always need post-weld heat treatment, so we cannot exclude that feature. So in the case of this procedure and these materials, the temperature required is about 690 degrees Celsius. So this is a temperature below lower transformation temperature. So this is our situation. We have a post-weld heat treatment which temperature is below the lower transformation temperature. So we're going to fill our WPS with the indication of below lower transformation temperature. This means that our procedure, weld PQR, qualifies for post-weld heat treatment below lower transformation temperature. We cannot exceed that temperature. If we exceed that temperature, we've got to do another PQR, different one. So time range the sufficient for to obtain the required results. So now we go for other essential variable, and now we have 407.4. So this is our next essential variable, KW 407.4. For ferrous-based metals other than P number 7, 8 and number 45, when a procedure qualification test coupon receives a post-weld heat treatment exceeding the upper transformation temperature, or a solution treatment for P number 10H materials. So this is not applied to our situation, since our post-weld heat treatment temperature is lower than the lower transformation temperature. So we go on to the next essential variable, which is KW 408.2. This is from shielding gases. A separate procedure qualification is required for each of the following: a change from a single shielding gas to any other single shielding gases, a change from a single shielding gas to a mixture of shielding gases, and vice versa. Well, we know in our PQR we have two types of gases for each process applied. So for gas tungsten arc welding we have pure 100% argon, and for flux core arc welding we have 80% argon plus 20% CO2. So according to ASME section 9, we cannot change a single shielding gas to any other single shielding gas, and we cannot change a single shielding gas to a mixture of shielding gases, and we either cannot change in a specified percentage composition of a shielding gas mixture, and we cannot add or omit any shielding gases. So this means that we must maintain the gases that were used in the PQR. So the range of qualifications for the gases qualified by this PQR is exactly for argon for butyl, and 80% argon plus 20% CO2 for FICOL. When we talk about trailing and backing, since it was not used, we can say that it is qualified with or without those. So now we go to the next essential variable, which is KW 408.9, and this is refers to backing. For group welds in pin number 41 through pin number 49, and welds of pin number 10 to pin number 10J, pin number 10K, pin number 51, etc. These are pin numbers that are not the same as the ones used in our PQR, so this essential variable is not applicable to our situation. So now we will move on to the next essential variable, which is for KW 408.10 shielding or trailing. And now we also have pin numbers described that don't match our pin number used in the PQR, and so this essential variable does not apply to our situation. So we move on to the next one, which is KW 409.2, and this is the transfer mode. About the transfer mode: a change from globular spray or pulsed spray transfer welding to short-circuiting transfer welding, or vice versa. So we must assure that our transfer mode during welding our procedure test is not made in the short-circuiting transfer mode. So we now move on to our PQR, and we have this note that says that mode or of metal transfer for GMO focal other than short circuit. Also in WPS range of qualifications we have other than short circuit, besides that any. So we mustn't have short circuit in our welding procedure test. So moving on to the next one is KW 410.64, use of thermal processes. So here we go. For vessels or parts of vessels constructed with pin number 11 and pin number 11B, base metals, weld growth less than. So this is does not apply to our situation, specific case, because these are different pin numbers. So we move on to next one. So this is the table for the essential variables for the process cast tungsten arc welding. The only two variables that differ from the process FCO is KW 404.14 that we're going to see in a moment, the deletion or addition of filler metal. Well, in the process, first of all, we want to add these indications. These are the electric characteristics of our PQR. So this the polarity, type of current, polarity, amps, the volts, the size of tungsten electrode, and its input approximately, and another comments. So in the technique we had this situation, the travel speed with multiple single. So in the WPS we must add that the filler metal cannot be deleted. This is applicable only to the guitar process. The next essential variable will be KW 410.11, a change from closed chamber to out of chamber conventional torch welding into pin number 51 through number 53 metals, but not vice versa. Well, this does not apply to our situation because we have totally different pin numbers. So this is it for now, and we have to indicate our electrical characteristics to range qualified in our WPS process with go. Filler metal can be anyone. Current type or polarity qualifies for anyone. Amps should be adequate, but it qualifies for anyone. Wire feed, anyone. Adequate voltage and adequate travel speed. In the case of additional comments or additional details from electric characteristics, we can say that pulsing current with or without is the qualification obtained. Heat input mass maximum anyone. Tungsten electrode size and type anyone. In case of technique, the string or weave bed, it's anyone is qualified. Initial and interpass cleaning, brushing, grinding, etc., any kind. Method of backgouge anyone. Oscillation anyone. Not define the contact to work distance. Multiple or single pass per side any. Multiple or single electrodes anyone. Electrode spacing anyone. Pinning with or without. So we have our WPS totally filled, and also our PQR totally filled.